So let's look at the red-black tree ground rules. Number one, the root is always black. By the way, there might be a time where we would do a rotation and then literally the root ends up red for just a split second. But then when the rotations are all done, it's literally turned to black. The root is turned to black no matter what, so bear with me. So root is always black. All paths from the root to the children have the same number of black nodes. It's coming up right now, and you can see, well, frankly, going down to every leaf, it took that many nodes or black nodes to get to the very top. And there's no path from the root to children that can have consecutive red nodes. So again, if you look in the entire tree, there's no back-to-back connections between parent and child of a red node. Now, things to notice: nowhere in the trees are two red nodes connected. Pick any path from the root, from the bottom, should have the same number of black nodes. Number three, though, is the important one. All nodes are ordered as a binary search tree. So all numbers that are in 46, everything is greater than 46 is on this half, everything is less than 46 is on that half. And again, well, pick any node, and it should be the exact same thing. But number four, notice this tree isn't perfectly balanced, but it's pretty close. It actually would be, again, if we had issues with the data ordering, it'd be pretty out of whack. But even this, with red-black trees, are not perfectly balanced. They're usually within 2 levels. And again, with the large data structure, 2 levels is nothing. You know, for a small tree like this, yeah, it looks like big. But I mean, if it's a massive red-black tree, 2 levels ain't nothing. So that's your ground rules for first example. Here's your example number 2. Doesn't look all that balanced, does it? But again, notice it's only 2 levels off, maybe actually 1 in this case. Okay, now this side seems to be a little heavier on the other side, but I can bet you right now, see all these reds that are at the bottom? Now, it doesn't look like a problem, but as soon as I add another red node to basically this side, except for over an 8, there's gonna be some rotations, and the rotations can be massive, whereas literally this becomes the root, this whole thing shifts over. We have child handoffs, which might be a nightmare, reoccurring nightmare for you. So a lot of things can happen with just one placement of the node and make this a heck of a lot more balanced than it previously was.